that's what I'll say. But with that, Brian, take it away.
All right, thanks for the introduction, and like it was mentioned, it's great to see such a good crowd here, and hopefully I don't disappoint. So yes, I'm from the National Drought Mitigation Center, and we're up in Lincoln, Nebraska at the University of Nebraska, and we are a national center that we cover drought across the country, and we also do a lot of international work. And I don't know what our track record is, but it seems like when we go around the country and do a meeting on drought or talking about drought, more often than not, rain either happens during or right after that meeting or right before. So no promises, but maybe we'll bring some moisture here too. So the topic today I'm going to talk for about 45 minutes or so on is looking at precipitation and drought here in central Kansas, and then also looking forward what to expect. So I'm going to really talk about some of the current conditions, talk about some of the work that I do, but also look at some of the trends. We've heard that our climate is changing, and so I'm going to talk a little bit about that. And I'm not going to say one thing or the other, but I'm just going to show the data. I let the data do the talking. And then I'm going to go into some projections, where we're going at this spring into the summer. And then the final few slides I'm not going to spend a lot of time on, but there are probably some people in the room that are interested. We do hear about a changing climate, and so I'm going to have a few slides at the end. Well, what happens if these projections that we've been hearing about come to fruition, 30, 40, 50 years down the road? And what does that mean here in your neck of the woods in central Kansas if that happens? So we'll have time at the end for questions. If I say something that you really need me to clarify as we're going through, just raise your hand. This is informal. I'm not going to be offended by any means if someone has a question and wants me to explain something a little bit more than what I go over it. And if I'm going to be standing over here, I'll move around. If I get in your way, just kind of shoo me and I'll scoot. So try to keep it a little light with a little bit of humor. And how many times have we felt this way, that it just seems like, we're doing everything the right way, we're doing what we should be doing, and then all of a sudden it gets dry and this drought comes along. And realistically, when we're looking at drought currently, and I'm going to have some products come up later, but central to western Kansas and into Nebraska, that's kind of been the epicenter of drought over the last several months. And so we've been dealing with this a lot. And again, sometimes it feels like that, we're, like I said, we're doing what we should be doing. We're doing things the right way, and Mother Nature doesn't do her part. And so we do deal with drought. Drought's not unique in this neck of the woods. It's part of our regular climate. Sometimes we go long stretches without drought to speak of, and we have plenty of moisture. Other times it just seems like we can't catch a rain and we can't get ahead. We're always behind. And that's kind of where we've been the last year or so. I'm going to talk a little bit more about that. But also, one thing to remember too is not every rain is equal, right? And the work I do with the drought monitor map, new map came out this morning. I'm going to show that later too. But rainfall and precipitation plays a big part in what we do with that map, but not everything. We are looking at things like soil moisture. We're looking at groundwater, rivers and streams. We're looking at the vegetation health, things like that. So there's a lot goes into it. We're just not focused on precipitation alone, but all the different pieces of the water cycle. So the National Drought Mitigation Center, we're up in Lincoln, Nebraska. We're housed at the University of Nebraska. We're what I call a soft money group. We don't get any money from our state or to run this center. We go out and compete for grants. So a lot of our research is geared towards drought, but we have different groups that we go to get that funding for. All the areas in the dark blues and the grays are countries that we've worked with around the world on this topic of drought. Back when we were founded in the mid-90s, a faculty member, started all this work in Lincoln, and he was an ag meteorologist by training, and he had an interest in drought, and no one else was working on this. Just in the mid-90s. And he retired with the nickname of Dr. Drought. I don't know if any of you have heard the name Dr. Don Wilhite anywhere along the line, but all this work began because of his vision on looking at drought as a natural disaster. And prior to the mid-90s, that was not happening. But if we go back in time, groups like the U.S. Department of Agriculture have been trying to identify drought areas going all the way back. This says August 1934. I wasn't around. I don't think anyone in here was around. But we know that was in the middle of the Dust Bowl. And they were trying to show on this map that they published, severely dry, crops were very poor. And again, this was in the middle of the Dust Bowl. And people have always wanted to know what's going on. Now that we're in a global market, you not only want to know what's going on around you, but in other areas, but the entire country or even around the world. And so going back in time, the drought has always been a topic for people to learn more about and wanting to learn more of why it's happening. And so before I continue, just a quick show of hands. How many of you in here are familiar with the U.S. Drought Monitor map? I think most people have been exposed to it, if not follow it each week. And so the Drought Monitor actually started in late 1999, and the official archive starts in 2000. And so when we look at the state of Kansas as a whole, and these are the different levels of the drought monitor, from the abnormally dry in yellow to the exceptional drought in the dark reds. You can see that, again, drought is pretty common. Like I said earlier, it's part of the natural climate of Kansas and the Great Plains. And so seeing drought episodes should not surprise anyone. But with the drought monitor, you can see that not all droughts are created equal, just like not all rains are created equal. That, here in 2012 into 2013, that was one of the worst episodes that we've seen. And prior to that, things were pretty quiet. We got past 2014, and again, pretty quiet. A little blip here in 2018. And then really from 2019 going forward, it was pretty quiet again for drought. A few episodes here and there. But what this is showing is, there are times, here's the 40% line, where, over 40%, over 60%, almost over 80% of the state was in extreme drought. Now, when we're working with the drought monitor, extreme drought means about one in 25 year type of drought event. The dark brown is exceptional drought. That's about a 1 in 50 year drought event. So these are rare, severe, intense occurrences. When I take out the abnormally dry and moderate drought and just have the severe drought or worse, and so basically all the oranges, the reds, and the dark reds, you can see that through time we've had quite a few episodes, and this is just for the state of Kansas. It doesn't say exactly where. We could dig into that data and let you know, was it western Kansas, eastern, north, south, whatever. But you can see that through this time period here from about 2005 to 2011, hardly any severe drought in the state, so a good period. And then we had this, pretty intense situation, then another period where, we went a couple years, there was no severe drought in the state at all. And so when you start looking at these data, not only does it tell you that some of the decision making that you are all involved in is difficult at times, but we also don't know, is the drought that we're seeing going to be a 1 year little blip in the time series, or is it going to be this 4 year multi-year drought that it just seems like we're in the middle of and we can't get out of? And that's what, where we're at right now. Starting in late 2021 and going forward, we kind of have seen this drought developing here in the state. And I don't have that crystal ball to say, hey, I know it's going to be done this year. So again, we go into this production year, we take measure of how much recharge did we have over the fall and winter months? Did we get any soil back into that subsoil or even deeper soil moisture? And will we have enough to get things going? You know, the further west we go here and you get into some of the wheat areas, and especially down in Oklahoma and Texas, some of those areas just have not seen precipitation at all. And very similar to what we're seeing up here in western Kansas, especially southwest Kansas. So in the 23 plus years of the U.S. Drought Monitor, this was the absolute worst that we've seen it in Kansas according to the Drought Monitor map. And we can see that this was in August of 2012, and it's hard to read up there, but we had almost 70% of the state was an exceptional drought. That, you know, things were about as bad as we'd ever seen them as far as the data that we look at. And almost the entire state outside of that north central part was in extreme drought or worse. And so this is where we were back in 2012. Well, how do we compare that to where we peaked in November of 22? So last fall is where we actually saw the peak of the drought statewide in Kansas. And since then, we've seen quite a bit of improvement in northeast Kansas, the eastern part of the state here. But it really seems like, you know, you draw a line about right through where we're at here in Reno County, and you go west and south of that area, and it's been tough to break. And the weather patterns have not been favorable to show this. And we've seen some improvement, but really not in this part of the state. It's been more to the north and to the east. And so when we peaked, just to compare, so back here we were right at 70% of the state was in exceptional drought. And this one here we were only at about 38%. And but that's still saying that a big chunk of Kansas here, we were dealing with this drought, especially here in the western and the southern parts of the state, and right where we're at here, definitely could see what was going on. So, that's kind of where we've been here just in the last couple decades. So when we start looking at some of the longer term patterns over this part of the state, what does that mean? And this picture caught my eye, someone's dock at a lake, the way it looks like, and you can't read it up here, but that's 3 foot below where the water line should be, and it's all the way up here. It was almost 4 foot down, and that was pretty common across not only this part of the country, but in other parts of the plains as well this last summer, where we just, we saw this water just disappear. So I pulled up the data for Reno County, and these data go all the way back to 1895. And when we look here, it says that the mean or the average is right at 27.5 inches. That should be about where we're at, give or take, in any given year. And so you can see that, we've had 4 instances where we've had 40 inches or more in a given, and this is for the calendar year, so this is January through December. And then we've had some instances where, we've been below 15 inches. And some of you may remember those dry years in the 60s or even in the 50s. I wasn't around then, but I do. My grandparents were farmers up in Nebraska, and they actually said that the drought in the 50s was worse than what they had in the 30s. And so, again, where you're at in your perspective is all going to be relative. So one thing to remember, though, is when you look at this line, outside of these 3-4 dots right here, here's another one, couple in here. Out of these data that go back almost 130 years now, there's only been a handful of times where you hit the average. Every one of us watches the weather on the news, and they say, we should have been 60 degrees today. That's our average for the state. Well, statistically speaking, you don't hit that average on the nose too often. That's pretty rare. But you can see there's a lot of variability. And you can also see in these data that you've had some wild swings here, especially in the 50s. You went from 5-6 years of very dry conditions, then you shot up to have one of the wettest years you've ever had. And we can see that, here's the 2011, 2012, then you shot up in 2013, one of the wettest years we've had. And I think that's the hard part of all this, is we're really trying to determine where are we in these swings. Are we really seeing another year that's going to be down here? Are we, is 23 going to be like 22 and be quite a bit below that average? Or are we going to see this big jump? And that's the problem. We have a hard time, even with as good of technologies we have and all the different models that we look at, and the meteorologists have a hard time really figuring out what that swing's going to be. But I could pull these data up for almost every county in the state of Kansas, Nebraska, Oklahoma, all the way into Texas and even the Dakotas, and you're going to see something similar. Basically, the high plains or the plain states have this level of variability, and we have these wild swings. And I'll talk more about that as we go forward. So the wettest year, 1951. And so kind of remember back, the average was about 27.5. So we go back to the wettest year that we've ever seen here in Reno County, and that was in 1951, 42 inches. And then what happened in the mid-50s? The bottom just fell out. Went from this really wet year to several dry years. The driest year was 1966 with just over 14 inches. So again, go back with a mean or average of 27.5 and you're down at 14. We've had years where you can be 10, 12, 13 inches below normal. The most recent year in the top 10 was 2011, which was ranked number 9 all time. But then 2012 was the 10th driest as well. So you really saw those two back-to-back years. And there were some areas in 2011, the further north you went from here, was extremely wet. And so again, short distances, you could see this variability. And I guess my message in sharing this is the variability is tough for us to get an idea of when it's going to happen. But these wild swings makes it even harder, because we don't really know, are we going to hit near average, or are we going to really be above or below? And so when I throw a trend line on this data, so the trend is trying to tell us, well, where are these numbers going over time? And this is precipitation again. So the blue line is the trend line, and up here in this circle, it says that for each decade since 1895, we've gained about 1/3 of an inch of rain. So if we look at where we were here to where we are here over, 11 decades, that's about 1.3 inches wetter. And this is in Reno County. This is smack dab where we're at. So it's actually gotten wetter in this part of the country. And many of you will scratch your head and say, well, yeah, I've seen that, but has it gotten wetter when we need it to be wetter? And I dug into the data a little bit, and actually the summers have gotten drier. The falls have gotten drier. Where we're seeing that increase in moisture has typically been in this winter and spring. And depending on the year, it's really hard to utilize that extra precipitation. I'm going to talk a little bit about that on some other slides. But so again, don't be fooled by the numbers. I can tell you that the data are showing here in Reno County it's gotten wetter over the last 120 years. But that moisture doesn't necessarily mean that it's been utilized or being able to be used by producers or others here in the region. And so then, instead of just looking at the county, I was curious to see, well, what do the data look like if I look at the whole region of south central Kansas? So, we're right here, and Kansas, that's Climate Division 8. So I kind of debated, should I look at Division 5 or Division 8, since we're kind of right in the middle. But the data actually didn't change a whole lot, so I just left the Climate Division 8, which is all these counties here. And this is the Palmer Drought Severity Index. It's been around since the 60s. It actually was invented by a USDA scientist that was originally from Nebraska, if you can believe that. But he wanted to have a kind of an agricultural drought index. And you can see that over time, again, here are these 50s, here are the 30s, 1980, the 88 drought, Later on, we can see the 2011, 2012, but you can see also that if I kind of concentrate from about 1975 on, this part of the graph here, we've had way more wet years than we've had dry years. And even the drier years that we've had, again, this is just the Palmer Drought Severity Index, and even the drier years, the worst ones were here in 2011 and 2012, where we hit a -4 on the Palmer, which is a pretty good drought, but not like when you're hitting -7 here in the 50s. You know, the severity was there, but just not as severe as other episodes. But you can also see that some of these periods have been pretty substantially wet in south central Kansas, and that kind of leads to that fact that, like I mentioned, some of the data are showing that it has gotten a little bit wetter in this part of the country. And if you really chop it off, again, right at 1970 and look backwards, a lot more drier years that we dealt with, it seems like, overall. So it's just something to think about. I know with my work with drought, human nature has been that the current situation is the worst it's ever been when I talk to folks around the country, or the wettest year we've ever had was the last one we've had. But when you start looking at the data over the long term, you can see that again, there are differences when we start looking at longer time series. And so I actually pulled up the data here for Hutchinson. That there's the data out at the airport, I think it is, or no, 10 miles southwest of Hutchinson is a National Weather Service cooperative site. And I used the standardized precipitation index, which basically is another drought index that we look at. And when I ran the data, and these data, you can't read it there, it's from 1953 on. So there's a good 80 years of data almost coming from Hutchinson. And what we found is severe drought is common about 20% of the time here in Hutchinson, you know, here in Reno County. And when I looked at these, there was 42 drought episodes during that time. The longest lasted 81 weeks, so about a year and a half. The average duration is about 17 weeks. So when we get to that severe level of drought, they tend to stick around about 4 months, give or take, on average. And then, you know, time in drought, it was right 20.08%. And so you can see that if I'm trying to plan for both the good and the bad years, about 1 out of every 5, we're going to have drought that we're dealing with. And typically when that drought sets in, we're going to see it for 4 months. Well, what's 4 months? It's pretty much a growing season. So it really depends on when that drought initiates, that once it gets going, it seems like they don't go away too quickly. So just some numbers, and these are hard to read, but the longest one was that drought in the 50s. That was 81 weeks. And how we determined when a drought ended was when the drought index went back to 0. So basically this is saying on the standardized precipitation index, that drought index at a -1.5, which would be severe. It took 81 weeks from March of 1954 to October of 55 until it got back to 0 again. So there was enough precipitation for that to take place. 55, again, we had consecutive years, so we went from 81 weeks to 52 weeks. So you got to think, well, in a 3 or 4 year period, we're in drought, a severe drought nonstop here in the mid-50s. 1980, 1988, here's that 1966 drought, but that was a little more short-lived. 63, 71. So you can go, and I will say that all these data are available online. And I did not put the links to them up there, but I did say that I'll dig through and share the data links. So if any of you want to go in and play with these data, they're all online. This is a tool that we developed in my shop so people could get an idea of just how to plan for drought where they're at. So what's going on in the region? This picture actually came from the 2011-2012 drought here, right here in central Kansas. And you could see even then the variability of the corn crop that year from no yield to stunted yield to decent yield, depending on where you're at. And sometimes that's all that matters in agriculture is the timeliness of rain and then the timeliness of the heat. Of course, you don't want to have a nice hot 2-week period during pollination, but if you catch a couple rains during that time, your yields can change tremendously based off of 1 or 2 rain events. And that's kind of what I'm going to show here. So I pulled these data. Again, these maps are all online, and I can share where to get to those as well. So this is looking for the calendar year. And this is departure from normal precipitation. And the yellow is about 3/4 of an inch below normal. Everything in the green is above normal. And so, here we're about anywhere from right at normal to maybe 3/4 of an inch above normal for the calendar year. And why don't I get too excited about that? Well, what's the driest time of the year in this neck of the woods? It's the winter. You can swing those numbers one way or another in a hurry, like we've seen up here with maybe 1 or 2 pretty good rain events. And so this is one perspective for the calendar year. This is kind of where we're at. You can see that much of the state did see above normal precipitation so far this year. That's a positive. Compared to where we were in 2022, I'll take this. And we go back to October 1st. So this is what we kind of use in the western U.S. as the water year, the recharge period as well. We know that agriculture is done by then. Anything that happens is moisture going into the soil that's going to be banked going into the next year. Well, when we start looking back to October, right here, about 2 inches below normal since October, which again, the fall into the winter is kind of a drier time of year. If we wouldn't have been building on a drought, that probably wouldn't get my attention too much, but since it had been dry already, this is problematic. And again, this area of southwest Kansas has definitely been under the gun longer, and I'm going to show those maps. But you look up here too, since last October, some of these areas 3-4 inches above normal right along that Missouri border of the Kansas City area south. And so again, the high variability, and we've kind of seen it's kind of a dividing line here, but then down into Oklahoma, we've seen it recently right in here too, that if you're west of that line, you just haven't picked up the rains, and that includes southwest Kansas. But if you're east of that line, you've had an abundance. So this is going back 6 months to last September. And where we're at here, about 3 inches below normal. So going all the way back to September, you can see that, a deficit. Now, remember what our average was. It was around, 27.5 inches. So not, about 10% below where we should be going for an annual, if you go back that far. And we go all the way back to June. So we got about 9 months in the bank right here. And again, you can see that, all of a sudden we're 6 to 9 inches or 9 to 12 inches below normal in the county. And even worse, if we go down here, 15 inches below normal. And this is just in the last 9 months. So again, we have almost a full year, and we go back a full year, and you can see again, about 3 to 6 inches, maybe approaching 9 to 12 down in that part of the county. But the hot spot really has been in west central Kansas, where they've missed out on about 15 or more inches of rain. And so if you think about, again, what that annual average was, so this is in a 12-month period, it's not January to December, but you're talking about right at 50% of where you should be. And that's, again, this is where we've seen the drought developing. And even in some of these areas in the last year, we can see that there's been some areas of seeing above normal, but really it depends on when that rain came and how it came and how is it being utilized. So we go back 2 years. So this is the last 24 months. So this goes all the way back to March of 21. So March of 21 to March of 22 to March of 23. And we focus in on where we're at, 12 to 16 inches below normal. And again, we can see these other pockets that have been drier, but we also continue to see east central Kansas stand out. If we go back 3 years, and I think this is what really caught my eye when I started looking at the data, was, okay, we're anywhere from 16 to 20 inches below normal in the last 3 years. So that's telling me that we've almost missed out on an entire year's worth of precipitation out of the last 3. And some of these areas out west definitely have done that. And that's where we are seeing the problems. That's where we saw the drought not only develop, but the intensity has been there, and it has stayed there, because even when we see some good rains like we've seen over the winter and some good moisture, when you're still showing a deficit, including those rains that we've seen, again, 3/4 of an inch above normal over the last couple months isn't going to cut it when we're trying to fix a deficit that's upwards of 20 inches. I just threw one, this is going back 4 years. And again, there's a dry spot right over this area that over the last 4 years, that's 16 to 20, 12 to 16 in the red. So again, over the last 4 years, there's been consistent dryness pretty much on the western quarter of Kansas, but then also in this area of the state that we're in right here. And that's where most of the problems that we're seeing have been developing. So this was the U.S. Drought Monitor map from last week, and I pulled it up, and it's highlighting Reno County. And looking at just Reno County here over the last 6 years or so, you can see that prior to this drought, there were some dry episodes, a little moderate drought, a little severe drought in 2019, but since about 2018, we had a stretch of about 4 years where conditions were pretty good. But then I just showed from about 2019 on, it's been dry. And the Drought Monitor maps actually picked that up quite well, because it's been consistently dry on the Drought Monitor map with extreme and exceptional drought during that time frame. And so the scary thing is for me, and again, I don't have my crystal ball, I don't know if this period is, year 2 or 3 of 5, or is this going to abruptly end and change? That's the hard part. We're going to talk about that a little bit, but that's the hard part. And here is my crystal ball, and I'm going to try and show, at least with the tools that we have available, and these are tools that you all can follow as well too, of what are we expecting going forward here in 23. So this is the Drought Monitor map that came out this morning. It comes out every Thursday morning, 7:30 a.m. You can go to the website and get this. And I looked at Kansas, and there were a few minor changes up here in north central Kansas, but for the most part, this map didn't change from where we were. So currently, we are at about 65% of the state is in severe drought. 52% is in extreme drought, which is the red or the dark red, and 35% is in this exceptional drought. And so that's kind of maintained itself for a while. If we want to compare that to a year ago, well, a year ago, 75% of the state, 73% of the state was in drought. We're at 75% now. So in the last year, not a whole heck of a lot has changed. But what we have seen are these numbers of severity increase, where last year we only had about 1.66% of the state in exceptional drought. That number has jumped all the way up to 35%. And so not only has the drought kind of stood in place, but it's intensified as that intensity has expanded. So we do have a couple outlook products that are associated with the Drought Monitor. One is a monthly drought outlook, which is what I have up here for the month of March. And then I have another slide, which is a seasonal drought outlook, which takes us all the way through the end of May. What these products try to do is the Climate Prediction Center, which is the long-term forecasting branch of the Weather Service. They're out in Washington, D.C. They run through several dozen different models to get an idea of where changes are going to take place. And so they start with the Drought Monitor map at the end of February. and they show areas of potential change or improvement or worsening. So everything that's in red basically is saying the drought's going to persist. The area in gray is saying that the drought is going to remain, but could see some improvements, but it doesn't say, is it going to go from extreme drought to moderate drought? It just says some improvements. The green is drought removal is likely. So we are seeing some of that down in eastern Oklahoma up to this point. We've heard what's going on in the western U.S. with all the rains and snows and the mountains in California and that. And then in yellow, drought development is likely. And so we do see some more areas to the south here with drought developing. For anyone in the Central Plains especially, why do I look at areas to the south? It's because in the summer months, we know that most of the moisture coming into our region is coming up off the Gulf of Mexico. If we have drought to the south of us in Texas and in those areas, that air mass loses moisture as it moves north. And that means less rain in Kansas, less rain in Nebraska, less rain up in the Dakotas. So I tend to really focus on East Texas, South Texas, because those south winds come off the Gulf, and that's the moisture that we see up in our region. So this has taken us through March. So, okay, nothing too earth-shattering or too exciting, but then we go into taking us through the end of May. So this is for the season. It takes us all the way through the end of the spring. First, going to take us into the first part of summer. And we do see a lot of gray, which is drought remains but improving. So I guess you got to take that even with perspective. If you're in D3 or D4 drought and you only improved to D1 or D2, okay, you did see some improvement, which is a positive, but you're still dealing with this dang drought, right? So some of these areas in green we're really looking at, I again see that yellow developing to our south. Really got to pay attention to that. But we also see a lot of the western region, the central to northern plains, quite a bit of improvement taking place. Some of this is because in some of these northern areas, they have a lot of moisture locked up in snow right now. They've had some tremendous snows up in parts of Nebraska. Not where I'm at. We haven't hardly had any snow all winter. But northern Nebraska into South Dakota, North Dakota, there's a lot of snow with water in it, with frozen ground below it. So to see any benefit of that moisture, we need to see it melt off slowly, but we also need to see the ground thaw out before that moisture can get into the ground. So this takes us through the end of May. One thing I tend to tell folks is this is updated the third Thursday of every month. So we can go in here in a couple weeks. What are we today, the 9th? So we got a couple Thursdays to go, and we'll be able to see the update of this and see. I don't like to look at just this one map and make any decisions on what's going to be taking place. I want to see what the trend is. If I see 2 or 3 releases of this map and it's showing improvement or maybe drought being eliminated, I have a little more faith in that tool going forward versus just looking at this map and thinking that's telling me the whole story. So looking forward, these temperature and precipitation maps are also updated the third Thursday of every month. They also come from the Climate Prediction Center, and they basically are telling us where we are going to have chances of above or below normal temperatures, and then precipitation as well. So we'll start with temperature. We see that much of the southern plains and southwest is looking to have a warmer signal, and this is for June, July, and August, so the summer months. And this is basically saying that through much of Kansas that there is a higher likelihood of above normal temperatures through the summer months. This product is pretty consistent, that almost every release you see anymore tends to show a warmer signal in the southern U.S. And that's just the nature of how climate has been. Precipitation, equal chances, that's the no forecast outlook. Basically, they don't have any skill that they can say one way or the other that we're either going to be above like in the eastern U.S. or below in the northwest. So equal chances, basically saying it could be above, it could be below. There's not a strong signal either way. And then we go, this is August through October. See, here's the summer, and then I just picked up August through October here. And again, that warmer signal staying through the region, not much different. But we're starting to see a little bit of this wetter signal migrate its way westward a little bit out of the Ohio River Valley. And that's something to pay attention to too. And again, these are just guidance that it still has to happen. And it doesn't tell you through this 3-month period, could 2 months be below normal and 1 month be above normal and really above normal. So there's a lot of unknowns with just how these data come across. And over the last several winters, we've been hearing about La Nina and what that does to our winter. Typically, it means in the wintertime that we're warmer and drier across the southern U.S. and colder and wetter across the northern U.S., and that's La Nina. That's a cooling of waters in the Pacific. With El Nino, we have warming waters in the Pacific, and it looks like the prognosis is this is January, February, March, still a pretty good La Nina signal taking place, and then that goes away quickly, and then by April, May, and June, we start seeing El Nino form. And so what does that mean? And this is kind of all the different models that we look at, and you can kind of see the green line is the middle of the models there. And And what it is showing is here's your Pacific waters, and pretty much all of those models are showing that it's going to be warmer in the Pacific. Well, what does that mean for us? Well, typically in El Nino or La Nina, the strongest signal is in the winter months. So as we start seeing this in the summer, we can anticipate that maybe there's going to be a wetter signal across the southern U.S. and typically warmer and drier across the Midwest and warmer to the northern part of the U.S. Basically what El Nino does is it changes where the jet stream comes across the U.S. And this would be more favorable to a wetter condition, but again, the signal is strongest in the winter months. So really in the summer, there's not a whole lot I can say that, oh yeah, we're going to see a wetter summer or a drier summer, but we're really going to be waiting almost to next October, November to not only see if El Nino has developed, but does it start behaving the way it should. And the reason I say that is think about what we've seen across this part of the country this year during a La Nina winter, which is typically supposed to be the opposite. It's supposed to be warm and dry down here and colder and wetter up here. But this is the signal we've seen with La Nina. So again, they have to behave the way that we anticipate them to behave. And we've actually seen this drier signal over parts of the Midwest going forward this year. So as a climatologist, you kind of throw your hands up in the air and say, well, I'm going to keep watching this stuff and just see if a signal starts to develop. So how about longer term projections? So this is 2041 through 2070, and this is based off of the National Climate Assessment, where they're looking at concentrations of carbon dioxide in the atmosphere and what that means for temperature and precipitation. So when we look at this area going forward, again, we see wetter winters, wetter springs, drier summer, and somewhat drier fall. And that's kind of what I talked about earlier, but it still shows some of these areas 20 or 30% increase in precipitation during the winter and spring months. So again, when you're seeing more precipitation during a time of year that you really don't have as much use for it, I mean, there is a use, right? It does, some of that does get into the soils, some of it does refill stock ponds and things like that. But you know, summer would be ideal, but we're seeing the summer is actually getting drier. And so what does this mean? Well, this means on the Great Plains that we've seen since about 1960 forward, there's that wetter signal that we talked about. Remember I kind of highlighted 1970 on that longer term graph that I showed? And you can see that, you know, some of these areas 10 to 15% increase in precipitation. But that's on an annual basis. Again, it's, are you getting that precipitation when you need it? And then these are looking at temperatures a little bit. So with lower emissions, what this is showing is the hottest temperatures and where they kind of range. And then the change in the number of days where you're seeing these hottest temperatures. And you're starting to see that, there's going to be maybe 10 or 15 more days of really warm temperatures that we're not expecting. And if you go to the higher projections, the hottest temperatures are going to be more likely in the mid 90s to lower hundreds based off of here. And then the number of days, when you start looking in here, it's again 13 to maybe 18, 19 days more of those hot temperatures. Okay, so what about dry days? We all know that regular rain during the summer months is the best, right? We don't like to see 5 inches in 30 minutes and just see it all run off along with all the topsoil, but we'd rather see a drawn out rain event that we can capture and utilize that moisture. So what this is showing is the number of consecutive days of dry days. Okay, so basically looking at how many days are we somewhat seeing as far as in between these rain events? And historically we can go a couple weeks with some dry spells is what this is showing. This is showing that going forward we could actually see that increase the number of dry days in between there. But also what was curious to me is there are portions of the region that are showing that it's actually going to have more frequent rain during these periods. And then we can look at the higher emissions and those projected changes in consecutive dry days, about 3 to 4 more than what we're typically expecting. And again, those are just projections based off some other types of models that are looking at concentrations of carbon dioxide in the atmosphere and what that means to our changing climate. And I could do a whole talk talking about some of these projections going forward and exactly what does it mean. But my contact information is up there, my email, and I'll take any questions that you have for me now. Thank you. Yeah.
You're talking about when you had Reno County and went west. What's the difference in rainfall amount? I mean, as far as average. I mean, I guess my question is, okay, it's severe drought out there, but they're getting less rain. So is their average like 16 inches and they're only getting?
I get what you're saying. So yeah, when we're looking at the drought map and we're putting those numbers together, it is all relative to the area that we're looking at. So definitely Southwest Kansas has got a different precipitation number than South Central Kansas, and so you're right that they may have a smaller deficit overall, but their average is also lower as well. So instead of 50% of normal like here in Reno County, they're probably more 70 to 75% of normal with the same deficit. So it is relative to that area that you're looking at. That's a good question. Who else has a question for me? One over here.
And this group has been all about talking about ways to capture and hold moisture as much as we can. Are you working with agronomists either in Nebraska or other places on practices that help you infiltrate the rain when it does come and then keep it there?
Yeah, so the question was, are we working with any groups that are promoting soil health, for lack of a better term, that when we do get these rain events, it does a better job of holding that moisture? And we kind of consult with them. We don't directly have any of those folks on our staff, but we have done some work. I've actually done some work on some of the recent drought events, and the one that stood out to me was in the 2010 to 2015 drought in Texas and Oklahoma, the areas that had the better soil health actually fared much better because of their ability to hold that moisture. And then it did get to a point, there were some places in the Texas Panhandle that after 4 or 5 years of the drought that they had in the early 2010s, that basically the biological matter in the soil was so poor that even when the rains did return, it took a while for that soil to regenerate itself. And so that's kind of where the soil scientists were coming in and you know, what could we have done differently, or is there practices that we can promote that would save that delay, I guess, in responding once the rains do return after a drought.
I have another question too. I mean, you talk about average temperature, but what about nighttime temperatures? What are we seeing with those?
Yeah, so the question is, what about nighttime temperatures? And I didn't show that. I actually pulled that up for this talk, but I didn't show it. And most of the changes that we're seeing in temperatures are not your daily high temperature, but it's your overnight temperature. So you're spot on in that we are seeing, you know, the daytime temperatures in the summer months, say, you know, mid-90s, right? Pretty common. But what we're not seeing is those overnight temperatures relaxing and cooling off, and that's where we've seen the actual increase has been in those overnight temperatures. And that's more problematic, especially for plants. You know, they don't have that chance to respirate at night. And livestock, yes.
Following up on that question, what is causing that nighttime temperature to elevate now instead of staying lower before?
Yeah, so the question is what could be causing that nighttime temperature to stay higher? Part of it is the increase in moisture that we're seeing. That, you know, I kind of showed that graph of over time we've added more moisture into that canopy. We know that a moist air is going to hold that temperature better than a drier air that will cool off more rapidly. So that's part of it. Part of it has been the amount of solar, you know, less cloudiness as well, where you're kind of heating up to a point, but if you have clouds, it kind of holds that temperature in. So you may warm up quickly, but if the clouds dissipate, you can cool off quickly. So it really shows what's happening in the evenings too. I haven't seen the best answer I've seen has been the more moisture in the atmosphere. There could be local conditions as well, you know, stronger southerly winds. The comment I've heard from many over the last 10 years is it's windier than it used to be. And you know, you're pulling more of that warm, moist air up from the south off the Gulf, where in the evenings it used to kind of subside a little bit more. So that's playing into it too. Moisture in the atmosphere does play a big part of that.
Got a question.
Yeah.
So you mentioned that at least over the course of the future, there's like an anticipation for more precipitation in the spring and winter seasons, and then like more of a drier summer, fall seasons. But as far as like data on precipitation intensity whenever the rainfall events occur, is it anticipated to be more like what you're saying, like more intense rainfall events, like as in when it does happen it pours, you know what I mean?
Yep.
Less, you know, over the course of that time as well, and whenever you do have rainfall events.
Yeah, so the question was, with the changes that we're anticipating and some of that we're already seeing with precipitation, are we seeing more intense rain events and less rain events overall? And yes on both those. I actually was at a meeting last week out in Boulder, Colorado, with a bunch of scientists from all over the country, and that was a point that came up, is if we are seeing more precipitation, but we're seeing deluges versus, you know, 5 inches in an hour versus 5 inches over 5 days is two very different. But at the end of the day, someone's going to look at the data and say, oh, you had the rain you should have had. But everyone that was impacted by it knows they didn't get the rain they should have had, right? And so that's one of the challenges we're going to see, and we're already seeing it. So what we're seeing are longer dry spells, which I tried to show on that. We're already seeing longer dry spells, but we're also seeing less overall rain events, but we're also seeing more intense rain events. And so when you start looking, so the meeting I was at, the idea was, how can we develop a tool to measure effective rainfall? Because right now we don't have that. Unless you tell me that you're here in Reno County, hey Brian, it rained like heck last night, and hardly any of that rain went in the ground and 3 inches ran off. I wouldn't know that. So that was one of the outcomes of the meeting, is we need to have a tool where someone could pull up a map and say, hey, we know the rain rates were so high over this area that the rainfall that was measured, most of that ran off. And so we got to find a way to do that, because right now we don't have a good way other than word of mouth that you're telling me that's going on. But that's something we're going to anticipate more of going forward.
Do you have any correlation between bare soil and tilled soil to temperature and precipitation? Sorry, I can't even say that. Do you have any, during like May and June, where there's all the tilling and everything, do you see any correlation between that and dryness? Or
I haven't seen that, but that's actually a good research question. I imagine probably some soil scientists have dug into that more so than I have, but I myself have not been exposed to that.
If we might see, I don't know, there might be a change if there's more no-till.
Yeah.
So you might see an effect that way.
No, most definitely. I think you're right. That I think the topic is going to really start focusing on going back to your question or comment about soil health. That the healthier soil is going to have better infiltration. What are cover crops going to do? What are they going to add? And I think that whole discussion is going to start coming into play. And with that discussion, I don't know how much down here folks have talked about carbon credits as well, but that plays into that discussion as well. But I think in the long run, and again, I didn't even stay at a Holiday Inn last night, but my soil science attribute is a healthier soil is going to be more beneficial, especially in heavier rain events or even these spells where we have longer dry spells. And so promoting soil health overall, and some of that comes from organic matter, some of that comes from cover crops, some of that comes from tilling practices. All of that's going to start playing a bigger role as far as vitality of especially during drought. Well, and not even just during drought. These heavy rain events, again, like I kind of hinted at it, you don't want to see everything washed away either. You would like to have that soil have the ability to capture as much as it can, even in a high rain event or high intensity rain event. So soil health is going to have to be a discussion. If it's not already ongoing, I'm assuming it is.
So just to add something local on that, Brian.
Yeah.
We have actually seen that we have rain gauges across the watershed where people are keeping track of rainfall for us. And there's somebody out in Drought County that has one. She's surrounded by conventional till continuous wheat. And then we have other gauges throughout the watershed. We have one in Stafford County. We have one in around west of Andale. And so I looked at those three. And so this past year, in Pratt County, they had 13 inches of rain over a 1-year period. And it was west of Andale, where there's more vegetation, more green vegetation. It was about 22 inches. So there's quite a gradient there. I realize west to east you get a little bit less rain west, but even Stafford County runs higher than the one that's right in kind of in the middle of the conventional continuous wheat. So I think there is something to that, to the bare soil and the green vegetation. Well,
and you bring up another good point that we know just how rain events are here on the plains, that from one end of the county, north, south, east, or west to the other, you can have a huge difference in rain. And even from field to field, you could see this. And I don't know how many of you record precipitation on your farm or ranch or both, but there's a couple programs. CocoRa's, has any of you involved in CocoRa's or CocoRa's observers? That the more people that we have utilizing programs like CocoRa's, where everyone's using the same 4-inch rain gauge, and we can kind of capture some of these variables, it's helpful. Plus, there's a reporting part of that CocoRa's form that you can tell me, and these data go directly to me, how dry. It's called a condition monitoring report. You can say it's wetter than normal, it's drier than normal, it's right where it should be, driest it's been, wettest it's been, and we collect all those and we archive them as well. And that helps a lot with some of the drought work that we do too. So we could do a whole talk on CocoRa's too. So I mean, it's a neat way. We call it citizen scientist of becoming involved with that. And if you do have questions about that, you can email me. I know a little bit about it. Actually, I know the national coordinator, but
I'm actually the Reno County coordinator.
Oh, you're the county coordinator, okay. And it's March Madness right now, so we're trying to get more observers signed up if you're interested. So. Oh,
That's right. We have rain gauges at the office.
okay.
We can provide them to you if you're going to record it. If you're just going to use it recreationally, we might charge you for it.
I just sent a bunch of gauges down to the folks in the U.S. Virgin Islands. They were interested in getting started. You have a question?
Yeah, like the other day, rain was different, but we got about 7/10 inch rain the other day, nice rain. If you get a 2-inch rain in the summertime when it's 100 degrees, which one does the most good as far as your drought monitor, or does it make any difference?
The way we look at it is a lot of that data is put into one of the various drought indices we look at that where precipitation pushes it. 70 hundredths this time of year probably does a lot more good because less demand, it's going into the soil. It's not all evaporating. 2 inches when it's 100 degrees, that could be gone by the afternoon, and it probably is. The other thing I'll say with the drought monitor too is we hear from the Kansas State Climate Office. They provide weekly updates on what they've talked to Extension and people around the state and kind of give us feedback too. So it's not like we're just looking at the data, but we do hear from people in the state. Chip Redmond, I don't know if any of you know Chip, but he kind of took over for Mary Knapp's position in the State Climate Office when she retired last year. So we do hear from him. But you're right. And it kind of goes into what I was talking about earlier. We need a way of measuring the effectiveness of a rainfall. That 2 inches in the summer when it's hot probably has a fraction of the use that 70 hundredths in March did as far as getting into that soil and being there later when you needed it. Got 2 questions over here.
My question was about, is there any consideration as to our orbit around the sun?
Yeah, you're right. We could talk for a while on this. There's been a lot of people that have done work that have showed, especially drought, is cyclical, and they have tied it to solar paths, right? And so there's the problem with that is you can see the cycles in the data. I mean, they do kind of match up, but it doesn't necessarily tell you exactly where that's going to happen. So if you're hitting a cycle where you typically have seen drought, it kind of throws the warning signs up a little bit, but it doesn't say, is that going to be in Kansas? Is it going to be in Georgia? Is it going to be in Washington? That, sometimes those are displaced, but there has been research done with that, and it's an interest. I haven't dug into it myself. I've dug more into looking at tree ring data going back 1,000, 2,000 years to see these similar cycles, but I haven't done that with really any of the modern data.
So Stacy had a question back there.
Yeah, right.
So I'm a firm believer that La Nina for us sucks. leads to drought. So can you explain, it looks like we're coming out of it. How long does this cycle between La Nina and El Nino? Is there a correlation, or we don't know, or?
Yeah. So yeah, so we just had our 4th straight winter of La Nina. And you're right, we've had the signal's been all over, especially the last 2 years, kind of opposites. 3 years ago, it was really wet through a lot of the plains in a La Nina winter. So the thing I've been seeing for the last 15 years or so is I've seen El Ninos act like La Ninas. I've seen La Ninas act like El Ninos. I've seen both of them not act at all like anything. And so waiting for them to do what you think they're going to do, that's tough. They do transition pretty rapidly. So like I showed up there, we are going to go from La Nina to El Nino pretty quick. I mean, in the matter of 3 to 6 months is pretty darn quick as far as the oceans switching their signal from being cooler to warmer. So we'll wait to see if that happens. That's supposed to be late spring, early summer. Then we can start preparing ourselves if that signal's going to hold on into next winter, where there's the strongest correlation as far as what it means to our weather patterns.
And you act like it does not affect so much in the summer?
Yeah, the summer is
that because you can't read, you don't think it affects the weather, or they can't tell if it is?
There's not a strong correlation one way or the other. It does impact the weather patterns, but it's not a wetter or drier signal or hotter or cooler signal. There's nothing that it really pushes one way or the other. Especially the winter is a stronger signal for both.
I'm an hour west. In 2012, it rained every week, but Medicine Lodge had 100 degrees over 100 days.
Yeah.
And that rain, there's usually 10 to 30 hundredths, and I would say effective rainfall, some of those were just almost meaningless.
Probably zero.
It was hot. Also, when it does rain, we tend to get, we'll have 24 inches average, but we tend to get a third of that in 1 week or 1 month. And you're telling me you don't really separate that out as far as?
Yeah, so when we're doing the drought work and the data is being looked at for the drought indices, it doesn't tell me how that rain came. For Medicine Lodge, it says 10 inches over the last 3 months. I don't know if that 10 inches came in 3 events, 20 events, 5 events, or came in 6 hours. So
we get 8 inches in 5 days, and really, especially the till ground, they just don't get the value out of it.
Sure. So that's what we really are lacking, is a way to identify that effectiveness of the rainfall and how good it is. I don't really have I'm going to use 2002 as an example. We were dry as can be up in eastern Nebraska, and August hit and we ended up with like 14 inches of rain. So for the year, we ended up well above normal. But it was one of the worst years. None of it happened until maybe helped some of the soybeans up there, but most of it was even past that point. And so if I'm just strictly looking at some of these numbers, 2002, well, that year was just fine. But if I go back and look at some of the other data, drought was pretty bad, and yields were impacted, and forage was impacted, the cattle were. So it's one of those things that I've learned you can't get too hung up just on the numbers. There has to be the value of those rain events.
Would you do that somewhat with measuring forage or measuring yield?
Yes, and the soil moisture measurements that we get, those are things I can look at and see that, hey, we had this rain and none of the moisture got past the top 10 or 20 inches. Everything else stayed dry. Or this happened over 5 or 6 days and that moisture got all the way down to the deepest layers and more of the root zone of the soil. So those are different tools that I do have and I'm able to look at. We use a lot of satellite information to look at, vegetation and greenness and things like that. And so those are helpful. So that's why we just don't, I always try to say it's not just precipitation. We're not trying to recreate where it rained and didn't rain, but we're looking at all that different data and different tools.